This is the last question in the homework. In 4.4, the very last question is this. I kind of alluded to this last class at the end of class. Can we look at these pictures? The blue guy is F. The red one is G. I don't know how good that shows up. But anyway, what is this one? When is f of x less than g of x? When is f of x less than g of x? So I guess visually that means when is the blue function lower than the red function? Or when is f lower than g? And I think f is lower than g kind of right in the middle here. It looks like the blue is less than the red. The f is less than the g, starting about right there and then over to about right there. You guys agree? Looks like f is less than g in between that little area. And so what are those x values? And there's a choice there. They kind of look like in between x values. I guess it looks like between -3 and 1. Between -3 and 1. That's what that looks like. Do you see that anywhere? Which one? D. D. No, I guess it's not working. You're wrong. No, I'm kidding. Sorry. Same joke. 3 weeks later. Yeah, I think you're right. D. Right. Bubble it in. Should work. What else we got? That was easy. Cool. That was too easy. Yeah, it's kind of interesting, I think. Easy too, but kind of interesting. Look at this one. Here's a function, and the question is, when is it greater than 0? See, what I do when I read it to you, I kind of interpret it into regular language. I mean, solve f of x greater than or equal to 0. So anyway, visually, when is this function greater than 0? And I would say, when is it greater than 0? It's almost hard to say. I think the answer is always. Right? It's always above 0. There's no time when it dips below 0. So it's, when is it above 0? Always. When is it below 0? Never. I think that's my 2 answers. What does this say? Solve when it's greater than or equal to 0. I'm saying always. Right. Bubbling it in. Yeah, that's it. All real numbers. When is it less than 0? Never, huh? That's what I'm saying. Never. Not with that picture. Okay, cool. That was easy. Again, I'm going to flip around here and try to find some good stuff. If you have, that's a better one right there. If you have a particular request, something you want me to look at, let me know. This is this absolute value. It's not on the test. Do you want help with it anyway? You might want help because it's in your homework. But it's not on the test. It's not on the test. Does anybody remember how to do it? When I taught it, I said it wasn't on the test, so maybe you didn't even think too hard about it. It's one of these absolute value less thans. That's a classic. That's where you take it and you make a sandwich. You make it between 8 and -8. I mean, if this absolute value is going to be less than 8, it needs to be between 8 and -8. It's very logical to me, but I might not explain it too well. Maybe I'll just tell you to do it. But that's it. If the absolute value is going to be less than or equal to 8, then it needs to live between 8 and -8. So now you proceed to solve this. By the way, then this will be the answer right here. But I'll just have to fill in the correct numbers, I suppose. It's easy to solve, right? What do? Add 5, add 5, add 5. That gives you 13. That gives you -3. Divided by 4. -3/4 and 13/4. Yeah. So just fill those in. That's that answer. Again, I'm not putting absolute value on the homework. On the test. Sorry. This one might be on the test. This is good. Kind of easy too, actually. Let's do this one. It's a quadratic inequality, and my theme was, I told you, you can't trust this. You cannot trust this. So you sort of pretend it's equal. Pretend it's equal. Solve it. It's easy to solve. You move the x squared over. You square root both sides, and you get plus and minus 4. You guys with me on that? Maybe you saw that coming. It's kind of... Anyway, but now, on a number line, where is it? Is it the numbers between -4 and 4? Or is it on the right side of 4 and on the left side of -4? It's usually either the middle stuff or the outer stuff. The sandwich or the wings. That's usually what it is. It's one or the other. I should actually maybe just pick a test point. That's what I taught you. I can't trust the inequality until I test it with a 0 or some number in one of these regions. I'll try 0, I'll plug it in here, and what does it say? It says 16 is greater than or equal to 0. When you plug a 0 in there, well, that's 16 greater than 0. That's true. Just pause for a second and think about that. But it is true, and if it's true, you shade that region, and that's the answer, and it won't be that region. So now where is that? Oh, cool. A. Right. You might have heard me say that when it's less than, it's the in-between stuff, and when it's greater than, it's the outside stuff. You know, I never meant to officially say that because it's wrong. With that negative sign on that x squared, that sort of changes things. Anyway, you better test it, maybe. You better find your answers and test the region to see what region is true or false. Okay, cool. It could get worse if I had some nasty square roots. This one might be good. I don't know how much homework you've done. Have you guys done this homework already? 4-4? Let's work on this guy. I mean, this was, so I just messed around with some inequalities. Okay, that was the end of 4-4. But at the beginning of 4-4 was this big idea. Solving these big, nasty square root equations. So you know the concept, square both sides. Square both sides. But first, I think I should move this 4 over. So I'm blowing it up here for you, and I'm making one little move here. I'm going to move that 4 over, so on the other side I'll have an x plus 4. Now, why did I do that? So I could get this square root by itself, because then I'm going to square both sides, and it'll be easier just to pop it out of the square root. When you square the square root by itself, it's easy, man. It's just 7x plus 36. On the other side, you got to square this, which means you got to FOIL the binomial and square it on out. So here we go. Squaring this is 7x plus 36. And squaring this, FOILing it out, in my head, is x squared plus 8x plus 16. That's what FOILing that out will give you. So we got some work left to do. It's quadratic. If it's quadratic, well, at least there's no more square roots. That's cool. No more square roots. But it's quadratic, and I should move everything to one side, get it equal to 0. I'm going to subtract the 7x. That'll give me an x over there. I'm going to subtract the 36. Subtracting 36 is negative 20. Hey, this ain't too bad. I think I can factor that. I'm going to move right over here. I think I can factor that. X and x. 5 and 4, don't you think? 5 and 4.
5 and negative 4.
Yeah, right. How about a positive 5 and a negative 4? Yeah, positive 5 and a negative 4. Yeah, that'll do it. Wait a minute, when I say that, positive 5 and negative 4, those are the factors. When you set these equal to 0, the answers are, setting this equal to 0, the answer is a negative 5 and a positive 4. So those are the answers. The factors was x minus 5. I mean x plus 5. The answer is negative 5. set each factor equal to 0. Cool, we got our answer. Maybe I should type those in as answers, but don't forget, on these kind of problems, we got to check our answers. We got to check our answers. It's possible that we got one wrong answer or two wrong answers. Not because we did anything wrong, but when you square both sides, that can happen. Well, so let me check -5. How do I do that? I go back to the original problem, maybe that original problem or this original problem. Well, before you squared it. I'll go back to the very original problem. I'll plug in a 5. -5. Let me see what happens. If I plug in a -5, that's -35 plus 36 minus 4 equals a -5 over here. I plugged in a -5 for x. Is this true? That's a 1. Square root of 1 is a 1. 1 minus 4 is a -3. Nope, that's not true. So he didn't check. So this is not an answer. Please don't give me that answer. Let's try 4. I better check x equals 4. I'm checking x equals 4 and plugging it into the original problem. That's 28 plus 36. That's interesting. 28 plus 36 minus a 4. Does that equal x, which is a 4? Well, maybe it does. That's 64, I think. 64. The square root of 64 is an 8. 8 minus 4 is 4. 4 does equal 4. That's true. He checked. Woohoo! We got one legitimate answer. The other one we toss away. I'm going to type that in. That's the answer, 4. Cool. All right, let's get out of here. Maybe. I'm going to back up into 4-3. Anything on your mind in 4-3? Backing up into 4-3. That was all about inverse functions. If I'm starting at the back of the homework. That might be a good question. Are these guys inverse functions? Are they inverse functions? I'll get rid of all my junk here. Any ideas, you guys? What do I do here? I don't know. We can mess around with this homework and see what we find. I think, and I probably would find a question like I'm about to propose. I think a question I prefer better is to find his inverse. Like if I asked you to find his inverse, here's this g of x is 7x cubed plus 3. So maybe I would just instead of giving you both of them and saying, are they inverses of each other, which is a good question, I might give you this question. Here's a function, can you find his inverse? And there was a method to that. There was a Smith method, and then there was a book method. The book method was cool. The book method says switch x and y. So this becomes x, this becomes y. And now solve for y. And that'll be the inverse function. You switch x and y, and then you solve for y. So solving for y will require me to move the 3 over. X minus 3, divide by 7. You guys agree with that? Move the 3 over, divide by 7. And now to solve for y, I would take the cube root. So y would equal the cube root of this whole thing. So that's my inverse function. The original function was called g. This is now called g inverse. I could erase the y, but this is g inverse. Anyway, that's what they're calling f, and they were asking me, are these inverses of each other? That's one way to sort of prove it. Go find his inverse, and it happens to be that dude, so yeah, I guess they're inverses of each other. Do you know the other way to prove it? If you compose them, which is in section 4.2, if you compose them, they should cancel each other out. In other words, if you do f of g of x, you should get x. So you could try that. Maybe that's more work, though. Maybe that's why I went that route. Maybe that was smarter and easier. But when you're presented with two functions, they ought to cancel each other out when you compose them or plug one function into the other. We can try it. Watch this. If I take this g and plug it into f, I'm plugging it into that x. This is a little tricky and a little tiny up here, but this is the cube root of, and what am I plugging in for x? 7x cubed plus 3. That's plugged in for that x. There's a minus 3, and then there's a divided by 7. Now when you work this out, it's beautiful. The 3's cancel. The 7's cancel. I'm left with the cube root of x cubed. Can you tell me what the cube root of x cubed is?
X.
Good job. It's x. And that's the proof that they're inverses of each other. They canceled each other out. They are, yes, they're inverses of each other. Technically, the proof would require me to actually check the other one. I did f of g of x and proved it was x. Technically, you should do g of f of x and prove that it's also x. Then you're darn sure. I'm already darn sure. Cool. What else we got here? Oh yeah, I never have tried this one. Have you guys? Well, good luck. I don't think I want to, yeah, whatever. I don't think it's a test question, but it's a homework question. It's something about coding and decoding. It's probably, there's some code that uses a function, and then to decode it, you got to use an inverse function. I mean, I haven't really read it yet, but that's the idea. You hear me? There's some kind of code that uses a function, and then to decode it, you use the inverse function. Each letter of the alphabet gets a number. Number 27 is a blank. We can convert this to, we can encode a message by adding 3 to each number. Oh. So like if I want to, oh, Jesus. All right. Thus the message go for it can be encoded by using the numbers, represent the letters, and then use this function. Right, so what's a G? A G is a 7. But when you don't want to use, you want to code it, so you want to call a G a 10. You want to add 3. Go, what's the O? O is 15. But what did they write? They wrote 18. All right, cool. So what am I supposed to do? Find the inverse function. Oh, well, that's easy. I thought there was a real code going on here. What is the inverse function of x plus 3?
X minus 3.
X minus 3. Right. You don't do the Smith method or the book method, or you can just go with common sense. If one function adds 3, the inverse function subtracts 3. Thank you. Is that all this is asking? I thought this was high classified military coding going on here. I mean, they explained the coding to me, but then they didn't make me, that's the next part? Mm-hmm. Oh yeah, all right, good luck with that. Decode that message. Just subtract 3, look at the chart, come up with the words. Yeah. Hopefully it doesn't have any nasty, profanity or anything like that. Good, that's cool, good luck. Yeah. Cool, that was fun. Uh-oh. This might be a little problem. Have you guys done this one? For many species of fish, the weight is a function of the length. W equals kx cubed. Interesting. Where k is a constant depending on the species. Oh yeah. So if k is a 0.025, W is in pounds, X is in inches, so the weight is this function. Yeah, so they've got this weight for a certain species of fish. What do? You measure the length, plug it in here, cube it, multiply, you get the weight. That'll be done. X is the length, and you got this formula for the weight of the fish for a certain species of fish. Find the inverse of this function. Okay, I guess I can find the inverse of this function. I would probably do that book method again where you switch X and Y. All right, this is Y, this is X. All right, I'm switching them. I'm going to call this X. Maybe I'll just, instead of Y, I'll call it W. Is that okay with you? But now I got to solve for W. Any suggestions? Divide. Thank you very much. That was good. Divide. Any other suggestions?
Take the cube root of it.
Take the cube root. So now, this W, yeah, maybe I shouldn't use W. I think I'm confusing myself. Because this is not weight anymore. Yeah, I just confused myself. By switching the X's and Y's, that is a good method, especially when the X's and Y's don't mean a damn thing. They're just variables, X's and Y's. Switch the X's and Y's. But when they mean something, that's a little dangerous. Hang on a second. This is the weight, this is the length. You know what? I don't think I am going to switch them. I think I'm just going to solve for X. I'm solving for X. I'm not switching the variables. I'm not switching the variables. So now what do I have? So up here, if you had the length, you plug it in the formula and get the width. Now, I'm not the width, the weight. If you have the weight, you can plug it in this formula and get the length. And switching the letters confuses you. It makes you think you switch. That's not good. Find the inverse of this function. All right, that's it. And they do want me to type an X in there. What does the inverse function give? I think it gives for the regular function, you type in length and it spits out weight. Right, you guys?
Right.
For the inverse function, you give it the weight, and I'm sorry, the letters have switched. You give it the weight and it spits you out the length. That's what happens. So, I don't know if I really want to type this in. Let me try to, can I get this wrong? Am I allowed to get it wrong? Can I go to the next part of the question?
You have to get it wrong like 3 times and then it'll...
Oh, I went to the next question. I didn't want to do that. I had to get it wrong 3 times. So, all right. Well, I should just type it in. But I know you guys don't like me to type. Let's just answer these without typing. What does the inverse function give? I think the inverse function gives you length. Use the inverse function to find the length of a fish that weighs 25 pounds. That's a nice hint. So you would plug 25 pounds in there and you could get the length. Right. In the context of this application, what are the domain and range of the inverse function? Hang on. What's the domain and range of the original function? I think the domain is length. I think the range is weight. When you have an inverse function, those things have switched. So the domain and the range are switched. So now The domain of the inverse function is weight, and the output of the inverse function is length. They've switched. All right, let's move on. That's a good problem. Can you choose this one? This has to do with our shifting and stuff. This is a good little problem. They have this function, the cube root of x minus 1. Listen, this is a function, and we know a little bit about it. We got a basic shape that we've studied, and we know how to shift it. I'll remind you that the basic shape is this sideways cube root function here. But how's it been shifted? How has it been shifted? To the right one. He's right. So it goes over to the right one. So this function, g, is, let me shift it. It's this guy shifted over to the right one. All right. Choose the correct graph of this guy and his inverse function. His inverse function would be the mirror image of this. You know, if this is this kind of sideways snake that hits at 1, then his inverse, I think, would be this one that, if he hits the x-axis at 1, the inverse is going to hit the y-axis at 1. And it's going to be this snake. Wow, that looks like it too, doesn't it? That looks like a beautiful mirror image. So that's my picture. I developed it myself. I got some multiple choice answers over here I could pick from. Which one does that look like? C? Looks like C, I think. Cool. All right, I'm trying to go back through this homework here. We just did that one. Find the inverse. We practiced that already today. Find that inverse. That might be a good one worth practicing. There is a hard one in here, I think. Nah, that's not too bad, maybe. Okay. All right. All right, I'm going to hit pause just a second.